In got it 4, we need to take the graph of log of base 4, describe the domain, the range, the y-intercept, and the asymptotes. I should note that there was no y-intercept up above. Okay, there was only an x-intercept. Alright, moving on. Let's do 4a over here. Alright, we'll save b for the table. 4a. Well, the inverse would be y equals 4 to the x power. Okay? So what I'm going to do is I'm going to make that chart first because it's going to make life easier on me. -2, -1, 0, 1, and 2. Plug them in. 1 over 16, 1 over 4, 1, 4, and 16. And now what I do is I need to find the log chart. And that's the inverse of what we just did. So I just switch everything around. And I graph my points. 1 over 16, -2. 1 over 4, -1. Over 1 up 0. Over 4, up 1. Over 16, up 2. So that would be way over here. Let's see if I can count it. 9, 10, 11, 12, 13, 14, 16. Somewhere around here. Okay, try your best guess. Connect them. This one will go down. You need to show that you know it approaches but never touches. And continue this side. Let's talk about your domain. Your domain, x has to be bigger than 0. Your range is all real numbers because it goes forever up and forever down. And the y-intercept, there's no y-intercept. And the asymptote is where it touches but never it approaches but it never crosses. And that's x equals 0, or the y-axis. Part B. Suppose you have the following table to help you graph. Recall that these two are kind of the same. Complete the table and explain all your answers. Alright. I think to save some time, we're going to skip this. And I'll think about it and see if I want to come back to it later on. Alright, we have 2 more graphs to do. And just like before, you can move things left, you can move them right, you can move them up, you can move them down, okay? You can vertically stretch them, you can vertically compress them. All of that stuff still applies.